pancreatic, or prostate tumor, and is currently en route to another location in the multi-step process by which cancer spreads, known as metastasis. Doctors, scientists, and engineers are very interested in metastasis because it is at the root of over 90% of cancer deaths. But very few cancer cells are able to complete the process. Back on the human scale, I can tell you from personal experience that we humans are not designed to handle inclement weather. So when we travel from one place to another, we travel in vehicles that have been designed for our protection, and then we end up at a location that has been designed for our comfort. Unlike when we travel in relative safety, when a cancer cell leaves its primary location, if it's able to at all, it is unable to travel in that safety. It is unprotected as it is rushed through the bloodstream, presenting highly inhospitable conditions to the cell. Assuming that hasn't killed it, it then has to leave the bloodstream and settle at a secondary location, which has not been designed to host a cancer cell. The cancer may lay dormant, again, if it even survives at all. But we are most interested in those cells that are able to survive anyway, because they're the most dangerous. To best isolate and study these cells, we engineers come in to design specific technologies to isolate these cells that are inherently dangerous in their design. In my research, I work small, like these cells, using microfluidics, taking advantage of flow in tiny channels. In my work, I use these microfluidic devices that are smaller than a credit card, but the channels inside are only as tall as the diameter of a human hair. I isolate these circulating tumor cells from patient blood samples using interactions between the surfaces of the cell and the surfaces of the chip to try to study these cells to see what makes them different, to see why these cells are able to survive when so many others are not. Our hope is that clinicians can then use this information to make better choices in patient care, to design better treatments, to neutralize the threat of metastasis. Thank you.